Hello students, once again welcome you to GK's maths classes. Today what we are going to do is we are going to continue with this chapter on functions. This is a part 7 of the video, where in the part 6 I have talked about what is a function, what are the different types of functions, and also we have done questions from exercise 1.2. So today what I am going to do is I am going to do more problems from exercise 1.3, even from miscellaneous exercise, and also examples, and maybe if one or two questions from outside the NCERT book. Okay, so I hope these videos will be useful to you. Let's straight away get inside this. Okay, now before I go to the problem, let me just quickly recap on what we have done in part 6, where I will put the description, where I put the link of that video in the description box for your complete reference. But today what I will do, I'll just give you a quick idea of what is a one-to-one function and what is an on-to function. So one-to-one function is also called injective function. So what is, if I say f is a function from a to b, and if I say it is injective, what does it mean? It means that if I choose 2 points x1 and x2 in A, in the domain, okay, if f of x1 equal to f of x2, obviously this is in B, because f of x1, it's the image of x under the function f. If this is true, then obviously x1 equal to x2. Or I have also told you that if f of x1 is not equal to f of x2, then you can always say that x1 is not equal to x2. So this is what is the definition of a one-to-one function is. Now what is an on-to function? F is a function from A to B, is said to be on-to, or another name for on-to is surjective. It is surjective when if codomain equal to the range. If codomain equal to the range, or every element in the codomain have a preimage. Okay, and also I have told you that f is said to be bijective. Said to be bijective. When is it bijective? If f is one-to-one and also onto. I think this is an exercise example problem. Now f is a function from natural numbers to natural numbers. Okay, where f of x, see, this is a function from natural numbers to natural numbers, and how it is defined as, it is defined as f of x equal to x square. F of x is equal to 2x. Okay, so to show it is one-to-one, what I will do, I will choose x1 and x2 belongs to natural numbers in the domain. I am talking about here, okay, where x1 and x2 belongs to the natural numbers in the domain. Now, as we know, if f of x1 equal to f of x2, if f of x1 equal to f of x2, you know by the definition f of x is 2x. So f of x1 will be what? It will be 2x1. And what is f of x2? It will be 2x2. So they get cancelled. You get x1 equal to x2. This implies f is 1-to-1. Now obviously 2x is an even number. So all natural numbers go to even numbers. Okay. So this is a 1-to-1 function. Now for onto. I already told you it's a natural number, right? So 1, 2, 3, 4 up to n. Okay, up to infinity. Okay, and here it will be 2, 4, 6, 8, 10, and so on. And 1, 3, 5, 7, 9, and so on. So when I combine odd numbers and even numbers together, I get the natural numbers. Of course, 0 is not included. Okay. Now all these numbers go to this under the function 2x. You see, every number here go to 2x. That means the odd numbers do not have a pre-image. Okay, so you can see clearly odd natural numbers in where in the codomain do not have pre-image. That means they are not mapped. Okay, they are not mapped. This implies we can say clearly codomain is natural numbers, whereas my range is only even natural numbers. So clearly codomain not equal to range. Since codomain is not equal to range, f is not onto. This is again a very, very important question, and this question is again from the NCERT book. So let us try to solve this problem. Now what is this problem all about? F is a function from where to where? From natural numbers to natural numbers. From natural numbers to natural numbers. Now how it is defined as? It is defined as f of x equal to x plus 1 if x is odd, and x minus 1 if x is even. Okay. Now I need to show whether this function is 1 to 1 or not. Actually they are saying show that. Sometimes they'll say check whether it is 1 to 1 and onto. So what do? There are different cases. So first I'm talking about 1 to 1. So case 1. Now what is case 1? For every x1 comma x2 belongs to natural numbers and both x1 and x2 are even. Let us choose that both x1 and x2 are even. Okay. Now if f of x1 equal to f of x2, so if it is even, what is the definition? It is x1 minus 1 and it is x2 minus 1, because both x1 and x2 are even. So they get cancelled, you get x1 equal to x2. So it satisfies the definition of 1 to 1 function. Now what is case 2? Now case 2 is for every x1 comma x2 belongs to natural numbers, here both the numbers are odd. Correct? Now if f of x1 equal to f of x2, by the definition when x is odd it is x plus 1. So x1 is odd, so therefore it is x1 plus 1 equal to x2 plus 1. So 1 gets cancelled, you get x1 equal to x2. So the function is 1 to 1 if both the numbers are chosen as even, if both the numbers are chosen as odd. But there's another possibility also, that is case 3. Now what is case 3? For every x1 comma x2 belongs to natural numbers where x1 is even and x2 is odd. Where x1 is even and x2 is odd. Okay. Now clearly it's meaningless to say x1 equal to x2 because even number cannot be equal to odd number. So definitely x1 cannot be equal to x2. Sure. Now what is f of x1? F of x1, since x1 is even, f of x1 will be x1 minus 1. Right? Now x1 is even. If you remove a 1 from an even number, it becomes odd. So clearly f of x1 is odd. That means what? All even numbers go to odd numbers. All even numbers go to odd numbers. Now f of x2, your x2 is odd. If x2 is odd, by definition it is x2 plus 1. So if you add a 1 to an odd number, the output is always an even number. So f of x2 is even. So once again, clearly f of x1 is not equal to f of x2. See, I have given you this definition, right? Look at this. f of x1 not equal to f of x2, x1 not equal to x2. So I'm using this criteria. So clearly f from natural numbers to natural numbers is 1 to 1, irrespective whether I choose both the numbers as even or both the numbers as odd or one even, one odd. So all the three cases must be discussed for 1 to 1. Okay. Now let us look at whether it is on to or not. Okay. For on to, what I will do, let's draw a simple diagram. Let me take natural numbers. Both are natural numbers. I divide the natural numbers as even numbers and odd numbers, right? So here this is x, x is odd, and here x is even. Once again, this codomain natural numbers can be divided into x is even and x is odd, right? Now, if x is odd, my f of x is x plus 1. So if x is odd, x plus 1 is even. So all the odd numbers, you see this? All the odd numbers, all the odd numbers go to even numbers. Alright? All the odd numbers go to even numbers. Now, what happens? All the even numbers go to odd numbers. Clear? So when x is odd, f of x is even. If x is even, f of x is odd for every x belongs to natural numbers. This implies my range is the entire natural number, which is also the codomain. Therefore, clearly, f is onto. Clearly, f is onto. So, one of the most important question in NCERT book, it has come in the board exam also. So, very, very, very important. I hope you understand this. Okay. Let's go to the next question. This is again a very, very, very important and this is slightly difficult question, where first time we are going to talk about modulus. Now here the function is from, look at the function, here the function is from real numbers to, it is less than, okay. So it is open interval -1, 1. It's open interval, my domain is real numbers, but my codomain is not real numbers, but part of the real number, that is -1, 1. And my function is defined like this. Okay. Now, first of all, you should know what is the definition of modulus x. So, what is definition of mod x? Mod x is defined as set of all x such that x is greater than or equal to 0, and it is minus x when x is less than 0. So, this is a very simple definition of modulus of x. Now let's redefine this function. How do I redefine? F of x equal to x by 1 plus x, x greater than or equal to 0, x by mod x is minus x, right? So it's 1 minus x when x is less than 0. All that I did here is I used the definition of modulus of x, where mod x is x when x is positive, mod x is minus x when x is negative. I hope that part is clear to you. Now what I will do, it is my job to check whether it is 1 to 1 or not. He is saying show that it's 1 to 1 and on to. Sometimes they will ask check whether it is 1 to 1. Okay. So let's see whether it is 1 to 1 or not. Now here again you have different cases. So case 1. What is case 1? For every x1 comma x2 belongs to R, where both are positive, where x1 and x2 both are positive. Both are positive. Okay. So what happens here? If f of x1 equal to f of x2, what is f of x1? f of x1, since it is positive, I have to use this definition. So it will be x1 by 1 plus x1 equal to x2 by 1 plus x2. Correct? Now just cross multiply. If you cross multiply, what do you get? x1 plus x1 x2 equal to x2 plus x1 x2. So clearly you can see x1 equal to x2. So it looks perfect, everything is normal. So it looks like if you choose both positive, function is 1 to 1. Now let's go to case 2. Now what is case 2? For every x1 comma x2 belongs to R, in this case x1 and x2 both are negative. In this case both are negative. Then what happens? If f of x1 equal to f of x2, what is f of x1? It is x1 by, use this definition, 1 minus x1. What is f of x2? x2 by 1 minus x2. Why am I using the second definition? Because x1 and x2 both are negative. If they are negative, this is the function. Now cross multiply, you get x1 minus x1 x2 equal to, cross multiply, x2 minus x1 x2. Now clearly they get cancelled. So what do you get? x1 equal to x2. Now that we have finished case 2. Now what is case 3? Case 3 will be, suppose for every x1 and x2 belongs to R, if you take x1 positive and x2 as negative, okay, so if you choose one positive and one negative number, obviously x1 cannot be equal to x2. Okay, now what is f of x1? F of x1 is x1 by, since it is positive, it is 1 plus x1. What is f of x2? F of x2 is x2 by 1 minus x2. So clearly you can see f of x1 is not equal to f of x2. This implies f is 1 to 1. So case 1, case 2, case 3, all three should be discussed for 1 to 1. Okay, so that finishes 1 to 1 function. Okay, now how am I going to go for onto? So let's go to onto. Now for every x belongs to R and x is greater than or equal to 0. First I am taking all positive real numbers. So when I take all positive real numbers, let's go a little slowly. My f of x is y. So my y equal to x by 1 plus x. Correct? X by 1 plus x. Now x is positive. X is positive and definitely 1 plus x will also be positive, right? So if the numerator is positive, denominator is positive, numerator is positive, denominator is positive, obviously the fraction will be positive, so that fraction has to be greater than 0, right? So can I say clearly, because of this reason, y will be greater than or equal to 0. Y equal to, because when x is 0, y will be 0. So definitely y will be greater than or equal to 0. Because numerator is positive, denominator is also positive. X is positive, so 1 plus x obviously will be positive. Is that clear? Now, clearly x is a positive number, right? So the next part of it, see the next part. What is the next part? X is positive, right? X is positive. Now what do you say about 1 plus x? Definitely 1 plus x will be greater than x, correct? Definitely, because x is positive, when you add 1 to it, so 1 plus x will always be greater than x, correct? So can I say 1 is greater than x by 1 plus x? I'm dividing by 1 plus x. Because 1 plus x is positive, nothing happens. So 1 is greater than x by 1 plus x. So can I say from here 1 is greater than y? Because x by 1 plus x is y. So from this can I conclude y is less than 1? Now what have we proved? When x is greater than or equal to 0, y will be greater than 0 and less than 1. That means y belongs to 0 to 1. Closed interval 0, open interval 1. Watch this very carefully. For this is the reason. Again I'll repeat. When x is positive, 1 plus x will be positive. So numerator is positive, denominator is positive, the fraction will be positive. So x by 1 plus x will be positive, so it's greater than or equal to 0. That clears this doubt. Okay, that is finished. Okay. For this is the explanation. Now for this, for saying y is less than 1, this is the reason. What is the reason? X is positive, so 1 plus x will be greater than x. 1 plus x will be greater than x. So 1 will be greater than x by 1 plus x. Now x by 1 plus x is y. So 1 is greater than y means y will be less than 1. So already you have y positive greater than 0, y less than 1. If I put them together, I get y belongs to, it is from 0 to 1, 0 included, 1 is not included. Clear? Now the second part. For every x belongs to R, where x is negative, watch this carefully, this is slightly complicated. X is negative, okay. What is my function? My function is x by 1 minus x. Correct? Now x is negative. So what do you say about minus x? Minus x is positive. Correct? When x is negative, minus x is positive. What do you say about 1 minus x? 1 minus x also will be positive. Greater than 1 or 1 minus x is positive. Now clearly you can see that numerator x is negative and denominator 1 minus x is positive. Numerator is negative, denominator is positive. So what do you say about a fraction? That fraction will definitely be negative. So it will be less than 0. Correct? It will definitely be less than 0. So from this can I say y is less than 0, and this is the reason. This is the reason for it. Why? When x is positive, minus x is negative. Sorry, when x is negative, minus x is positive. 1 minus x also will be positive. So numerator is negative, denominator is positive, the fraction will be negative. So negative means less than 0. So y is less than 0. That clears one part of it. Now what's the next part of it? The next part is y equal to x by 1 minus x. Y equal to x by 1 minus x. Now this is a very tricky step. Watch this carefully. Now what is this step? Y equal to minus 1 plus 1 by 1 minus x. If you take LCM, you see, if you take LCM, what happens? You get minus 1 plus x plus 1. 1 and 1 cancel, you get the same thing. I did not do anything great. I added 1 and subtracted 1 on the numerator and I splitted it. I add 1 and I subtract 1, nothing else. Okay, and I take suitable minus sign out. So I get y is minus 1 plus 1 by 1 minus x. So this is same as this. I hope that part is clear. Okay. Clear? Then what we do is, then this argument is little complicated. Listen carefully. You see, x is negative, minus x is positive, 1 minus x is positive. So numerator is positive, denominator is positive. So 1 by 1 minus x is a positive quantity. I won't say greater than 0, I say it's a positive quantity. So You see, this is minus 1. To minus 1, if I add a positive quantity, okay, to minus 1, if I add a positive quantity, see this is a positive quantity that is added to minus 1, definitely y will be greater than minus 1, right? If you add, for example, for with minus 1, if I add 0.1, okay, definitely the resultant number will be greater than minus 1. Sure? So clearly you see y less than 0 from here, and it will be greater than minus 1. Therefore y belongs to minus 1 comma 0. Y belongs to minus 1 comma 0. Now the understanding is like this. See, if I have a number line from minus infinity to plus infinity, and if I have a number line with minus 1 to plus 1, and this is 0, okay, included, all the positive numbers 0 to infinity, I am taking from 0 to infinity. Look at this. From 0 to infinity, all the numbers from 0 to infinity will go to 0 to 1. That's what I did here. See this? Y belongs to 0 to 1. And all the numbers from minus infinity to 0, from minus infinity to 0 will go from minus 1 to 0. Look at this. When x is negative, my y belongs to minus 1 comma 0. That means all the elements in the codomain is used, correct? Therefore my range is minus 1 comma 1, which is nothing but the codomain. Therefore f is on 2. So it's a very tough question. You have to be very, very careful with this. Is it clear? So I have proved 1 to 1, and I also proved on 2. This part you just rewind and see. It will take some time for you to understand. If you still have a doubt, please comment in the comment section. I will definitely get back to you. Okay. Now let's go to the next question, or maybe I'll just show you this problem in GeoGebra. Okay, I'll show you the graph of this function. Actually, this is very interesting graph. Look at this. It is actually x divided by 1 plus mod x. Look at this. X divided by 1 plus mod x. So look at this graph. X divided by 1 plus mod x. If you look at the graph very carefully, okay, this covers the entire real line, okay, whereas the graph don't take any value beyond 1 and minus 1, and also 1 is not included, minus 1 is not included. Can you see the graph? This graph will never intersect 1, and it will never intersect minus 1. So your range is open interval minus 1 comma 1. Okay, so you can also see, when if you watch this very carefully, all the positive real numbers gets mapped to 0 to 1. Can you see? It's from 0 to 1. This part of the curve is from 0 to 1. 0 is included. And all the negative real numbers gets mapped to minus 1 to 0. Therefore, f from r to minus 1 comma 1 is on 2. Is it 1 to 1? Very simple. Draw a horizontal line. The horizontal line will intersect the graph only at one point. If the horizontal line intersects the graph at one point at a time, then you can say it is 1 to 1. So clearly we have proved it is 1 to 1 and on 2. So this graph, the graph helps you to understand the question. Okay, I hope that is clear. Let's go back to the problem. Okay, the next question. I have a function f. Let's go back to this. F is a function from where to where? Natural numbers to a new set y. Now what is this new set y? The new set y comprises of squares of natural numbers. That means we'll have only 1, 4, 9, 16, 25 and so on. So it is given n square where n is a natural numbers. Okay. Now f is a function from n to y. Now I have to check whether it is 1 to 1 or not. Now for every n1 comma n2 belongs to natural numbers. Okay. F of n1 equal to f of n2. If it is equal, clearly n1 square equal to n2 square. Here to take square root, I don't have to worry much because n1 and n2 are positive because they are natural numbers, right? n1 and n2 belongs to natural numbers. So I don't have to worry about plus or minus. This implies f is 1 to 1. From where? F from n to y is 1 to 1. Correct? Now is it on to? Let us take an example. 2. Okay. Check whether it is on to, right? F from n to y. What is the range? My range is nothing but y. Why? 1 goes to, see for example, if I take natural numbers 1, 2, 3 up to n and then so on. 1 go to 1, 2 go to 4, 3 go to 9, n go to n square and so on. Okay. So every element here gets mapped. So my range will be y. My range is also equal to what? Equal to codomain. Therefore, f is on to. Or in other words, if you have y equal to, if you have y equal to n square, so n is nothing but root of y. Okay. So what is root of 1? Root of 1 will be 1. Root of 4 will be 2. Root of 9 will be 3. Root of 16 will be 4. I don't have to worry about plus or minus. If it was r to y, then it is a problem. If it is r to y, it cannot be 1 to 1. It cannot be on to also. But since it is from natural numbers to y, where y is not natural numbers, y is natural numbers, but it is only squares of natural numbers, 1, 4 and so on. So every element in the codomain is going to be used, okay, under the function n square. Therefore, my range equal to codomain, therefore the function is on to. So the function is 1 to 1 as well as on to. Now this is a very, very important question. Okay? F is a function from n to r. Again, n is a natural number. Defined as f of x is equal to 4x square plus 12x plus 15. Show that f from n to s, it's a restricted codomain. N to s is 1 to 1 and on to. Let us see. For every x1 comma x2 belongs to natural numbers, if f of x1 equal to f of x2 implies, what is f of x1? 4x1 square plus 12x1 plus 15 equal to 4x2 square plus 12x2 plus 15. 15 gets cancelled. So I get x1 square plus 3x1 equal to x2 square plus 3x2. Now you have x1 square minus x2 square plus 3x1 minus 3x2 equal to 0. I brought all the terms to one side. So this is a plus b into a minus b, and 3 is out, you get x1 minus x2 equal to 0. Now what is common? x1 minus x2 is common. I will get x1 plus x2 plus 3 equal to 0. Now clearly x1 plus x2 plus 3 can never be 0. It can never be 0. Why? Because x1 and x2 belongs to natural numbers. So natural numbers are from 1 to infinity. So if you add them, it can never be. If you add positive numbers, you will never get 0. So obviously, if you want the product to be 0, x1 minus x2 must be 0, x1 equal to x2. In the exam, you have to make sure you write these reasons, otherwise they can cut marks. Okay, so be very careful with this. So this shows that the function is 1 to 1. Now I have to check whether it is onto or not. Okay, let us see whether it is onto or not. Now this is set of all natural numbers and this is set of all real numbers. Correct? I just have to show that one element here do not have a pre-image. Okay, so what I will do, I will take for example a 1 here. Okay, so put y equal to 1 and I want to find the corresponding x for that. So when I put y equal to 1, what do you get? 4x square plus 12x plus 15 equal to 1. Okay, so what do you get from this? 4x square plus 12x plus 14 equal to 0. Now 4 can be cancelled. You get 2x square plus 6x plus 7 equal to 0. Now let's find the discriminant. B square minus 4ac. B square is 36 minus 4ac. 36 minus 28 into 56, which is definitely less than 0. So no real value of x. This implies 1 do not 1 where in the codomain don't have pre-image. This implies codomain not equal to range. Therefore f is not onto. Therefore f is not onto. Okay. Here you have a function f from closed interval -1, 1 to real numbers. And how it is defined as f of x is equal to x by x plus 2. Find the inverse. This is from the old NCERT book, so we don't have inverse. All that I want you to do is check whether, you can say check if f is 1 to 1 and onto. Where? 1 to 1 and onto where? In the range from -1 to 1 to range of f. Okay. First, with the first part of the question is I have to check whether it is 1 to 1 and onto from R, from -1, 1 to R. This is the first part I need to check. So let's do that first. We'll come to the second part little later. For every x1, x2 belongs to -1, 1, okay, f of x1 equal to f of x2. So clearly what happens? X1 by x1 plus 2 equal to x2 by x2 plus 2. Cross multiply x1 x2 plus 2 x1 equal to x1 x2 plus 2 x2. So x1 x2 cancels, you get x1 equal to x2. This implies f is 1 to 1. Where f is 1 to 1 from -1, 1 to R. There is absolutely no restriction. From -1, 1 to R, it is 1 to 1. There is no problem. If it is 1 to 1 from -1, 1 to R, in the restricted region, what is the restricted region? My restricted region is range of f. What is this? We'll come to that later. Range of f, okay, is also 1 to 1. Okay. So for the time being, we take it for granted. We'll come back to this statement again. Now, you have y equal to x by x plus 2. You know, for finding onto, you find x in terms of y. So xy plus 2y equal to x. I cross multiply. Now from this, what you do? You take this xy that side. So you get 2y equal to x minus xy. Now what is common? X is common. You get 1 minus y. So what is x is equal to? 2y by 1 minus y. Definitely y cannot be 1. But he has given your codomain as what? All real numbers. All real numbers includes 1. So my if it is from minus 1 comma 1 to r, f is not onto. If it is from minus 1 comma 1 to r, it cannot be onto, because 1 cannot be there. Y cannot take values 1. 1 do not have pre-image. You can try it. If you put y equal to 1, you get x by x plus 2. If you cross multiply, you get 2 equal to 1 or something like that. You get x plus 2 equal to x. How is it possible? Meaningless quantity. So 1 cannot have a pre-image. If 1 cannot have a pre-image, my codomain and range, my range cannot be R. So codomain and range are not equal. Okay. So what happens here is I have say closed interval minus 1 comma 1. Okay. And here it is set of all real numbers including 1. Okay. Now first what we did, we proved that f from minus 1 comma 1 to r is 1 to 1. No issue. But now we have come to a situation where my range is not r, but range is something else. So my range will be no longer r, but it will be a subset of r. And I call this as range of f. Okay, which wherever for whatever value it does not have a pre-image, I eliminate that and I form a new set. So now f from minus 1 comma 1 to the range of f. Where is range of f? Range of f is in the real numbers. It's a subset. So f is from minus 1 to comma 1 to range of f for the values to take. That means every element in this red ball inside, every element here will have a pre-image. So codomain equal to range. Here my domain is codomain is range of f, and my range is also range of f. Therefore, f is onto. Please understand, again it's a little confusing. F is not onto from minus 1 comma 1 to r. Why it is not onto? Because there are elements which do not have pre-image. One simple example is 1. 1 cannot have a pre-image. It's very obvious. 1 cannot have a pre-image. So I eliminate that. Once I eliminate that, I get a new set. I call that new set as range of f. So now my function is not from minus 1 comma 1 to r, but it is from minus 1 comma 1 to the origin, to the smaller set. What is the smaller set? Range of f. So in the range of f, from minus 1 comma 1 to range of f, the function is onto. Okay. Now coming back to this, from minus 1 comma 1 to r, it's 1 to 1. When it is true for the larger set, it has to be true for the smaller set. Therefore, minus 1 comma 1 to range of f is also 1 to 1. So you have proved. First, what did you prove? You proved from minus 1 to r, it's 1 to 1. That you have proved. Now you have proved that f from minus 1 comma 1 to range of f is not only 1 to 1, but it is also onto. But from minus 1 to 1 to r, it is not onto. Okay, video. I hope you have understood this. In case you have any queries, any question, anything that you have not understood, please put in the comment section. I will definitely get back to you. It's very important you understand these things. Some of them are a little complicated also. So we'll see you in the next video. Kindly subscribe to my channel and also click the bell icon to get notifications. Thank you for your support. See you again in the next class. Have a lovely day.